Hello friends, today's question. A symmetric lamina of mass m consists of a square shape with a semicircular section over of the edge of the square as shown in figure. The side of square is 2a. The moment of inertia of the lamina about an axis through its center of mass and perpendicular to its plane is 1.6 ma square. The moment of inertia of the lamina about the tangent AB in the plane of the lamina is. We have to find out the moment of inertia through this tangent line AB for this lamina. So in order to solve this, we are going to use theorem of parallel as well as perpendicular axis. So we can say that if this is the center and we have our x-axis in this way and this will be our y-axis, and let this be the z-axis. So it is given that the moment of inertia about an axis through its center of mass and perpendicular to the plane. So it means we have in the question itself it is given the moment of inertia of this plane along the axis which is perpendicular to the plane and passing through the center of mass. So this is center of mass and we have z-axis which is passing through which is perpendicular to this plane lamina. Therefore we can say we are given Iz as 1.6 ma square. So you can say Iz, or you can say z-axis is z-axis passes through the center of mass and is perpendicular to the plane. Therefore, Iz is given as 1.6 ma square. Now we are going to use first of all theorem of perpendicular axis rather. Okay. You can say theorem of perpendicular axis, and this states that moment of inertia about perpendicular axis, moment of inertia about perpendicular axis is equal to sum of the moment of inertia about the two axes which are at right angle to each other and passes through perpendicular axis through it. When the perpendicular axis passes through it. So we have three axes, x, y and z. So moment of inertia along x-axis let us suppose is called as Ix. Along y-axis we are going to call it Iy, and along z-axis it is Iz. So therefore moment along about the perpendicular axis, that is z-axis, will be equal to the sum of the moment of inertia of the two axes which are perpendicular to each other. Here the two axes which are perpendicular are x-axis and y-axis, that is Iz, will be equal to sum of Ix and Iy, and all the three passing through the same center of mass. Therefore, from here we can say that our Iz is equal to Ix plus Iy, and we already know Iz is 1.6 ma square. So from here we can say that Ix plus Iy is equal to 1.6 ma square, and it is also given that the lamina is a symmetrical lamina. So therefore we can write that for symmetrical lamina, the moment of inertia along x-axis will be equal to moment of inertia along y-axis, or we can say I of x is equal to I of y. Therefore, we can say that 1.6 ma square is equal to Ix plus Ix, which is equal to 2Ix. So from here we can find out value of Ix. So we get Ix is equal to 0.8 ma square. Now we found out, let me draw the, so this is our x-axis and this is our y-axis, and we have a tangent which is AB, and this tangent is parallel to x-axis. So now we are going to use theorem of parallel axis in order to find out the moment of inertia about, you can say, AB, and we say that let this distance between tangent AB and x-axis is given as x. So you can say, according to theorem of parallel axis, moment of inertia of about parallel axis will be equal to sum of moment of inertia about the axis passing through the center of mass. So this is our center of mass, axis passing through center of mass, and product of mass and distance, you can say distance between the two axes, square of the distance of two axes. Square of the distance between the two axes. So it means moment of about parallel axis, it means IAB will be equal to sum of moment of parallel axis passing through the center of, so the corresponding parallel axis is Ix, so this will be Ix plus mass and the distance between the two axes square. And we already know that our Ix is 0.8 ma square. So here we write 0.8 ma square, and now let us find out what will be our x. Let me write this way. Okay, so it is given that it is a square like this, and we have a semicircle. Okay. So the side is 2a, so this is our 2a. So obviously this portion will be equal to a, as well as this portion will be equal to a. So we get total will be equal to 2a. So you can see from here that our x is equal to 2a. So this will be plus m 2a square. So therefore we get IAB will be equal to 0.8 ma square, plus this will be coming as 4 ma square. Therefore the moment of inertia along the tangent line to the given lamina IAB will be equal to 4.8 ma square. This is the moment of inertia about the tangent line AB to the given lamina. So in this case, both theorems are used, parallel as well as perpendicular axis, in order to find out the moment of inertia of the tangent axis. Now in this case we substituted Ix as Iy as Ix, because from the figure we can see that our Ix, so this is our Ix and this is our Ib. So Ix is in parallel with Ib. In case the tangent is in parallel with the y-axis, so under this condition we are going to substitute Ix by Iy. No doubt the answer will be coming same, but the tangent will be along parallel to the y-axis. So depending upon the where the tangent is, or rather to which axis the tangent is parallel, we can just manipulate the formula. Okay, so this completes the question. Thank you.